All right, good evening, everyone. This is Darren with the Austin Artificial Intelligence of Things. Um, Tonight we're talking about running C# on a Raspberry Pi and using it to power some RGB LEDs, most commonly referred to as neopixels, but these ones are the generic kind, so they're just WS2812B is their model number. Okay. And if anybody has any questions or anything, feel free to put them in the chat. Dave will go ahead and try to field any of those questions for me. And if he can't answer them, I will gladly try to jump in with them. And again, welcome, everyone. We are having a few technical difficulties, so I will try to work my way through our demo as best I can. End up missing as a result of the technical difficulties. So to get things started, let's go ahead and flip over to some code real quick. And everybody can hear me okay, correct? Okay. So this, the code that we'll be running tonight is actually a sample that is in the .NET IoT repository. Just to show you real quick. This is the repository by which it comes from. It's the IoT source devices samples. Hey, look, there's my name. I may have written this code and gotten it contributed. But yeah, so this is the sample we'll be running tonight. So what we'll be doing is keeping on with Visual Studio Code. So I have the sample pulled up here. The sample is fairly straightforward. It is, first we're creating it in the sense of a standard console application. So we have our static main to get started. Anybody who's familiar with C# should recognize the static main. Let me make this a little bigger for everybody. Come on. Okay, so the very first thing we're doing, we're clearing the console. We're setting an event handler for when the console when the cancel happens, or the Control C event, and then we're telling it to run. We have this nice run command here, in which we create a SPI connection. So contrary to the Python way of controlling these LEDs, where we actually used a hardware-based PWM to control them, here we're actually using the SPI bus to control it. We're using a 2.4 clock frequency here. We're using SPI mode 0 with a data bit length of 8. So utilizing the .NET IoT namespace and NuGet package, we're creating our SPI device, and we do have a compilation flag here. So if, depending on whether or not this is present in the compilation string, you will either get this version of it or the 2012B. The 2012B is the one we'll be using. So this is actually not necessary for us tonight, because we'll just be using this one here. And then we just create a standard infinite loop to keep the application running. And we have these nice helper methods that are actually doing the heavy lifting in terms of getting the LEDs up and going. The first one being color wipe. Or actually, let's just continue our cancel handler, like I mentioned up before, from here. So we have cancel handler. It's just clearing out the LEDs, setting them all to blank, then updating them all to be blank, and then clearing out the console. So that way when the application ends, you have an empty console. Now the color wipe, which is really simple, we pass it in a reference to our NeoPixel string, a color we want it to be, and how many NeoPixels we want to have that color. In our particular case here, we have count, which is set up here at being 8. For my particular string, and if you bought the same string that is in the description of our meetup tonight, this number should actually be updated to being 300 because it's a 5-meter string at 60 pixels per meter, so that's 300 pixels total. So we're just passing that count in, and then with the color string, we're creating a bitmap image using the image that is coming out of the our reference NeoPixel type, and then for each item in our list of our count here, so for every pixel we have, we're setting the pixel index, its line number, and color to being whatever color we passed in. And these are the standard .NET colors. If you're familiar with using like Windows Forms applications or trying to utilize colors and graphics from the .NET framework, these are the same colors and whatnot. So if you see, color.white, color.red, color.green, you could also use RGB values. So you could set it to being a specific color that you want to be. A little fun fact here is you cannot set a color to being brown on one of these light pixels. You can set it to being orange. You can set it to being a dim orange, but you cannot set it to brown. When it comes to light colors, brown does not actually exist. And so what that's going to do is we have 4 of them here. So the first time we go through, it sets the color to white. Second time we go through, it sets the color to red, green, blue, etc. Then we have Theater Chase, which Theater Chase is a fun one where it groups the LEDs into groups of 3. And for every 3 LEDs, the first one and it ultimately comes to being every other LED ends up being lit up. But it does it by groups of 3, which this is a really neat animation, and I'll demo it at the end once we get everything set up. And then wheel here is actually a helper method and here's that from ARGB I was talking about a second ago. This wheel here creates a color wheel. So you end up with a rainbow of colors going around your entire strip here. And then we have rainbow here that actually generates that whole rainbow and prints it out to the LEDs. Rainbow cycle allows the LED, is an animated version of the same thing where it just kind of cycles through the colors as the LEDs go around. And then rainbow theater chase is the same as the theater chase before, only this one uses the rainbow colors to do so. Yeah, that's it for the code. It's fairly straightforward, fairly simple. Now on to the hardware. If we look here, we'll be connecting to the SPI pin here, which is the blue wire, a ground pin, which is this black wire, and then because I have 300 LEDs, there's actually not enough power coming from the 5-volt pin on the Pi to power the entire string of LEDs. So instead, I will be leaving the red pin disconnected, and I have a separate power source for the LEDs. And I don't actually have enough wire to be able to hold it up to show it to everybody, but so with the separate power source, and the separate power source is a 5-volt 4-amp power source. But that is more than enough to power the entire LED string. And if you go ahead and connect the red pin, it will back power the Pi. So you need to be careful with that to make sure you don't accidentally back power it with too much power. Because the Raspberry Pi does not have the power protection on its GPIO pins. It only has it on the power input through the USB Type-C cable, since we are using a Pi 4 here. And because I have this already set up and ready to go on my Pi, let me go ahead and switch over to my console window. I have my sample here, and if we look, when I copied it copied over all of the DLLs and runtimes necessary to run this application on a Linux machine. This is a standard Raspbian setup. Nothing special has been done in terms of how we're setting up the Raspberry Pi. It's just it's a Raspbian Lite, so there's no UI involved with it. I'm connecting to it over SSH. I'm using an application called MOBA Xterm that also gives me an SCP as well as SSH at the exact same time. So I can actually see over here along the left-hand side. I can't make it any bigger for you, otherwise I would. I have essentially a file explorer. And so if we look, this is all those files that I just showed you over here. So now, if we come over here, and you see the ws28xx.strip.samples is green because it's executable, I can go ahead and execute that. And once I do, it'll actually start lighting up the LEDs that are sitting right here on my desk. And you'll, so I'm going to go ahead and run that. It's going to start up the LEDs with color wipe red. Let me go ahead and swap it so you guys can see. So now it's on the theater chase. So you have the nice theater chase LEDs. Now they're in blue. Here's the rainbow. I have a slight bug in Rainbow Theater Chase. Theater Chase is way too fast. I need to fix that still. But yeah, here's red. It's about to turn green again. There we go. And it'll just keep repeating until we swap out. And then, so if I go back over to my console, Control C, it clears everything out. And the LEDs are now blank again. So I know I went through that really quickly. And if anybody has any questions, go ahead and put them in the chat. I originally was supposed to cover setting up a debugger for a remote debugger for the Raspberry Pi, so that way you can actually step through the code. But that was part of the technical difficulties I ran into this evening. I don't actually have what I need set up to be able to do that. But in case those of you don't know, we are actually live from my new house this evening. I just bought a new house. If anybody has any questions or anything, feel free to put them in the chat, and Dave and I will try to answer them. All right, as far as back powering the Pi, would an appropriately placed diode solve the problem? That I am not certain. I am not well versed enough in um, circuit protection to be able to answer that correctly. I do know that if you are back powering the Pi, you have to make sure that you are giving it as clean power as you can. All right. Any other questions, comments? Um, at, at this point, I believe that is actually all I have to demo today. That demo went a lot faster than I was expecting. Um, wasn't expecting it to only last 16 minutes, but oh, how can I make the string longer? The LED string, you can actually make it as long as you need to. I believe um, you just have to be considerate of power. Uh, every 300 or so pixels, you're going to want to put a an inline power source, which the ones that I have here, and I can show you my setup. Now that I have unhooked them. The ones that I have here, on one end, this is the end. This is the end that you could hook another set of um, LEDs to, another strand, and then the inner end that I have here. This is the end that I was attached to, and I have this little adapter that I keep attached to my Raspberry Pi, and it actually plugs in just like it would if you're plugging into another LED strip. And then this is how I was this is how I was powering the LED strip with just a little um, barrel plug adapter. But if I had a second reel of LEDs, I could actually just take these two pieces, plug them in over here, and just have another power inlet going in to serve as power for it, and we could go that way. So just to hold this a little closer to the camera for everybody to see. I can do a quick recap of the first few minutes. What we did was we walked through the code um, on how to set up, walked through the code that's running the sample that I showed off tonight. Um, and as far as this being a workshop, setting up Visual Studio Code and setting up um, the Raspberry Pi itself, I wasn't planning on having that as part of the scope of this evening. Um, I was planning on actually doing an in-depth walkthrough and setting everything up, but I ran into a few technical problems this afternoon trying to get my laptop set back up to do it again, and I wasn't able to actually finish getting that fixed before this evening. So my apologies on that regard. All right. Well, if I were to start this over from the beginning again, just to show everybody what's going on with the going back to the code. It's just a sample. It's just a standard C# um, console application. We have it set for having 300 LEDs attached. We're creating yeah. Okay. So we're creating our Pixel device, creating a standard application. Oh, yes, thank you, Dave. That is the part that I had missed. I apologize. Um, Getting this to actually run on the Pi, that is the part that I had actually skipped. I apologize. Let me go ahead and skip over to the directory I have all this stuff in. So devices, open in PowerShell, open here. Okay. And you guys can't actually see any of that. So let me go figure that's not working. Okay. So in PowerShell, can I make that bigger? Nope. And I apologize, I can't seem to make that text bigger at the moment. Do a .NET build, and that will automatically build whatever projects we have in this folder. All right. I actually need to be in the samples folder. We need to do .NET publish -r Linux -arm -o. Let's put that in a publish folder. All right, that should go ahead and publish it for us. So now if we look, we have another folder named publish. We cd into publish, take a look, and there's all those files that I was showing you a second ago. So then samples, publish. I switch over to my terminal. And just as a heads up, I am actually not installing .NET on the Pi. This is .NET running as a standalone application being bundled as part of my application instead of being running on its own. So shrink that. Wait, let me flip over so you guys can see it. I can come back over here, come up one level. No, wait, cancel. That is not up one level, that is up one level. Go ahead and copy these 194 files into this directory. This is going to take a second, but not too long though. Yep, we're already over 100 files copied. Right. Right, and then just showing how I'm connecting these. The pins that I am using are these pins here. So, and in the case of these particular LEDs, the white pin is actually, or the white wire is the black wire in the fritzing app view. And then the green wire is actually your data in, which goes there. I do not actually know these exact pin numbers off the top of my head. I believe they are the ground and the MOSI pins. So if we go to pinout.xyz, the MOSI pin is pin number 19. And then the ground we're using is pin number 30. If you're using a short LED strand, like one of the 8 count ones, or one of the I would say up to about maybe 30 pixels total, you could go ahead and power from the Pi, at which point you would plug the red wire into one of the first 2 pins, either pins 2 or 4. But I'm going to leave mine unplugged. I'll go ahead and plug it back into my LED strip. Okay. Those .NET commands were being typed in PowerShell on my PC, so I'm actually compiling it for Linux, for the ARM-based Linux on my PC, and then copying the compiled files over to the Pi, and it comes with all of the necessary support files that allow the application to run, such as the support pieces of the .NET framework, because we are running .NET Core here. And the editor I've been using this evening has been Visual Studio Code. Let's see, give me code. There we go. Yeah, this is Visual Studio Code that we've been using this evening. You can get Visual Studio Code for free from the Visual Studio website, or I believe is just visualstudio.com. And then the terminal application I've been using is called MOBA Xterm. It's a really handy terminal application that gives me so many more tools than just a Linux terminal and my SCP or SFTP rather uh, menu down the side here. If I wanted to, I can create a new tab here, and it's another um, server window. I can go over here to sessions. I can create additional sessions, click the session button, and it does all kinds of stuff. FTP, SFTP, serial, file, shell, browsers, all kinds of stuff. All right. And then am I using a Visual Studio Code extension? I am actually using, Visual Studio will automatically prompt you to install its own extensions whenever you start working with a specific file type. So if it detects a C# file, it'll automatically tell you to install the C# extensions for it, which is kind of nice. You don't actually have to go out and seek out those extensions. You can just have them running automatically, or have them brought down automatically. And then as far as the GPIO pins are concerned, it's physical pin 19 and physical pin, I actually could have used physical pin 20 right across from 19. But as far as BCM pins, GPIO pin 10, also known physical pin 19, the BCM pin number is pin 10, physical pin number is pin 19, and if you're using wiring pi through Python or any of its various implementations, wiring pi is pin number 12. All right. And then just covering the code side of this one more time. I have my console application here, I have my terminal open with my SFTP window as well. I open my file explorer, which I don't actually have set up so that way you guys can see it yet. That's part of the technical difficulties I was running into. I literally just highlight everything in the file. So Control A, and then I copy over into the folder on MOBA Xterm, and it automatically starts doing the upload. And if you notice down here at the bottom, it's doing the upload down here in the corner, which actually you can't see my cursor, so you can't see that. But in the bottom left-hand corner is where the upload is actually happening. All right. Are there any other questions or anything? Did I cover it all? I'm a little scatterbrained at the moment, and I apologize for that. Okay, going back over to the repository, the main repository is .NET IoT, which is the .NET Core IoT libraries. To install these libraries, system.device.gpio and iot.device.bindings. Right now they are in pre-release status. But they are ready to use as long as you're okay with pre-release software. So recapping this from start to finish, we have our code, which We have our code. We then compile our code using, I use PowerShell to do it. So, and the command is .NET publish, and then we tell it runtime linux-arm, and give it an output folder of publish, let that run, and then oh, duh. All right, be in the correct directory first, and then run publish. Once all the files are published, you copy them from the published directory that we created here, copy those over to MOBA Xterm, where we have the files. I already have the files copied here. I've now copied them twice since we've began. You're going to need to go and find the WS 28xx.strip.samples and make that file executable. Once you do that, it's just a matter of // and then execute it. From the hardware side, you'll need to hook up the LEDs. So you'll have to have a power source for the Pi, a power source for the LEDs, and then on the Mosey and the ground pins for the Raspberry Pi, which I just screwed up mine trying to hook them back up. Oh, as far as on the Pi is where the files land on the Pi is concerned, they actually end up, if I go, they're actually in your home folder. So if I go up one more folder, we're in /home/ they go into the Pi folder, so your user folder. So right now, if you see, we're in /home, and I can do cd pi, and that's where our files end up. Assuming you don't put them somewhere else specifically on your Pi, you can put them wherever you want. You just need to make sure that you make the file, like the file that's named after your application, executable, and then you can just execute that file just like any other application on a Linux machine. So then make sure, and then going back to the hardware though, make sure that your pins, you're using pin 19 and then a ground pin on your Pi, and that you have a separate power source for the LEDs from the Pi. This does work with any of the Pis, the Pi 2, the Pi 3, and the Pi 4. It does not work with the Pi 1 or the Pi 0. They do not have the correct processor to be able to run .NET code on a Pi 0. .NET is supposed to be platform independent, but do you find there are any gotchas you have to work around to run on the Pi? The only gotcha I have found is you have to be considerate of the file system by which you're working in. If you're working in Windows and you need to access something from the file system from your code, then you can use Windows file system paths to do so. But if you need to access something from your code and you're running on a Linux machine, you have to use a Linux file path to do that. And Windows and Linux file paths have slashes in different directions. Luckily, Windows will translate them for you, so you can use the slashes in either direction, which is why I prefer to use relative paths instead of absolute paths, because if you're using a relative path and you know the path relative to where you are, then you don't have to worry about whether or not you're in the Linux file system or a Windows file system. it'll just work. But if you happen to have, if you have to use absolute paths, then you have to be aware of what environment you're running in. The only other gotcha I have ran into is make sure that when you're compiling on Windows for Linux, that you use the -R with either -R Linux, -R Linux ARM, or -R Linux x64 to make sure that you are actually compiling and getting all of the necessary runtimes for a Linux distribution of your application. So, any other questions or anything? Oh yeah, and if anybody has any questions or comments and wants to leave me any feedback, you can reach me at darren.swan@austiniot.org. We'll also leave my email address uh, in the chat, as well as on our. You can also reach me through our Meetup page that way as well. So, and I'll go ahead and put my email in the chat. All right. If there's no other questions or anything, thank you very much, guys. And we'll see you all at the next one. All right. Have a good night.